All right, well, let's go ahead and get started. Today is the beginning of our 25-26 Rector's Forum, and we're going to begin with a very light conversation about science and religion. No, it's a very important topic, of course, and one of the things that's a real blessing here at St. Paul's is that we have people with lots of different expertise in a variety of different areas, particularly in the scientific and medical areas. And one of our parishioners, Richard Simon, who is with us this morning, is a professional astronomer. Works at the National Radio Observatory, Astronomy Observatory, and is going to talk with us a little bit about where we are in terms of our understanding of the physical universe, but also on a more personal level about how he understands the universe and the mysteries of the universe and how that shapes his religious outlook. So, Richard, I thought we would start by just talking a little bit about the universe and its mysteries. And I understand you've got some images for us that we can access these mysteries, and it's not all that challenging with some basic equipment, right?
Yeah, and first, I just want to say thank you for inviting me. It's really, I'm very honored and happy to speak to all of you. If any of you have ever been up at Shrinemont and we have a clear night, you know that I'm happy to share because I feel very blessed to have been an astronomer. I'm aware of how fortunate I am, as we all are in so many ways. So what I have here, wait, I'm sorry, your question.
Just to look at the mysteries of the universe and how we can start getting at them through just images from telescopes.
Yeah, and the reason I brought this is that the images I'm going to show you were all taken fairly easily with this. These days you can buy a smart telescope. Pretty decent ones are less expensive than a cell phone. They're smaller than this, but you can take them out, set them up, and you can start taking pictures of stars and galaxies. There's a comet that I might try to see tonight.
Okay.
It was just appeared from behind the sun yesterday. Surprise. But the point is that these days with fairly simple equipment, this one has a computer in here, and there's a mirror back there, and there's an opening lens. This is not a telescope you look through. It's really just a camera lens that's controlled by a computer with a battery and some motors to point it. And so these pictures I'm showing you were all taken mostly in my backyard, some up on the Blue Ridge where I'll go where it's a little bit darker, but it doesn't matter so much. This first picture isn't that, it's a decent picture of the moon, but it's really to give you an idea of the scale of the things that we're looking at. This is about around half of what the image is of the field of view. So most of the things I'm showing you are about the size of the moon. There's a couple that are a bit smaller than that. And you can see them with binoculars, just you won't see them as brilliantly or in colors. The moon itself gets color. We had last Sunday, I guess it was, a blood moon. This is not that blood moon. This is from March when we had a lunar eclipse. And so this is from my backyard. I woke up, I went to sleep, but it was cloudy. I woke up at 3 in the morning and said, well, maybe it's clear. And I just took this outside, just like that, turned it on, and then started playing around with the controls on my cell phone and took this picture. So that's our neighborhood. Fortunately, the Earth doesn't look like this. We have a lot more air, water, and activity here. Let's see if I can do this. Yes. Okay, so this is an interesting picture, not only because it shows a really interesting part of our Milky Way. This is part of what's called the North American Nebula. And dare I say it, this is the Gulf of Mexico, and this is Mexico kind of curling around here. And there's a little tip of Florida. This is actually something you can see with binoculars by eye if your eye is dark. If the sky is dark and your eyes are well adapted. That this is big enough, it's near, but you have to kind of know where to look, but it's part of the Milky Way, and it turns out that the whole nebula that you see here, and I can only fit part of it in this image, is several times the diameter of the full moon.
Yeah, did you want to do it?
Oh, yes, that's right. Thank you. The line that you see going across is a satellite. And there are, 7,000 or 8,000 satellites in orbit around the Earth. And in this case, the image didn't filter it out. It was bright enough. Turns out the computer will kind of filter those out. So that's what that bright line is. If you look through a small telescope shortly after sunset when the stars are out, you'll see lots of satellites. You can always see a few at night, even by eye. So I wanted to talk, some of the mysteries that astronomers worry about are the births and deaths of stars. This is a region down, and again, this picture is, the moon would be about as big as the nebula that you see here. This is a cloud of gas and dust. It's called the Eagle Nebula. This is especially interesting because if you see right here, you see it's like an upside down eagle. But these three things are a very famous photograph that was taken by the Hubble Space Telescope called the Pillars of Creation. And it was just this spot here, and they just had a little bit, $1 billion and a little bit higher resolution. But the point is that the things that you see in these, here's a beautiful mystery of the universe, these things they're almost within touch. This particular picture I took when I was up on the Blue Ridge, and it's probably a half an hour or an hour long exposure, so enough light gets collected. But it's this is a region, what you see here is a star cluster and gas and stuff. It's actively forming stars. It's towards the center of our galaxy. And these stars here are very young, and they're lighting up all this gas and dust for us to see. This is another region. It's in the northern hemisphere. This is often called the Iris Nebula because it does have a blue color. The colors that you see in astronomical pictures are all a little bit heightened or adjusted because our eyes would be too faint to see these colors. If I did some better calibration, I could actually say this is the true color, but in fact, the idea is so you can see the structure and complexity of the nebula. What's going on here is that there's new stars that are forming. There's a lot of dust, and so you see the dust will give you a bluish light as it reflects, in the same way that smoke has kind of a bluish color. I should also say that all these little dots here are stars in our own galaxy. All the pictures have hundreds or thousands of stars. One picture, there's some of them here that have more stars in one picture than you can see with our eyes. This is another area of gas and dust. It's called the Trifid Nebula. This is one of the more famous ones also. And here you see the pinkish red color is hydrogen gas lit up by the stars. The blue is dust reflecting light. And again, you'll see there's a cluster of stars there. This one is kind of fun. It's gotten named the Pac-Man Nebula. And something that you see here and in other pictures is you'll see these dark areas. Those are clouds of gas and dust that are not lit up. It's like, think of it as cosmic smoke almost. It's not from burning, it's just dust particles. And when you try to look through a couple of light years of dust, it blocks everything behind it. And so there's a dark cloud in front of the brighter nebula behind it. Also, this one, again, you see here in the center, there's kind of a cluster of young stars, as well as the general background. And I should say that it's a little bit smaller than the full moon that we saw earlier. This is one that's been whimsically named the Elephant Trunk Nebula. I asked my wife what she saw, and she said, yeah, it's pretty, but where's the elephant? I said, well, where's the elephant? And he's got his trunk here, and he's spraying water over there. So if you use some imagination, you can see that. But again, it's an area where there's a dark cloud of gas and dust in front of a brighter nebula. And then you see these kinds of ionization fronts where when stars are young and very bright, they have a lot of ultraviolet light, and they will gradually eat away at the gas and dust around them. So you see these kinds of structures. Now again, we've been looking at things. Oh, this is one that's very famous. It's called the Horsehead Nebula, and this is in the constellation of Orion. This is very faint, but this picture is about an hour-long exposure. And it sounds like a lot of work, but I just take the telescope out, I click on my phone, and that's how these smart telescopes work, and I tell it go, and then I go inside and sleep. Or, more than one of these pictures, I can set it up at night, and then I go to sleep. I'm not as young as I used to be. But again, you see the hydrogen gas glowing in the reddish color, and then gas and dust in front of it. And there are many beautiful pictures of this taken with much higher resolution. But this gives you, and you can see also there's some young stars. Some of them have a glow around them because of the effects of optics. But this one down in the lower corner is reflecting gas and dust. This is the Orion Nebula. You can see this by eye as a faint fuzzy patch in the center of the sword of Orion. So you can see Orion's belt, and hanging down from his belt is his sword. And you see blue colors where it's reflecting. This picture is actually overexposed because this nebula is actually very bright. You can see it in binoculars fairly easily. And it's just, if you look around, I remember discovering this with my brother and I looking through a small telescope when we were kids. We were very excited. We could barely point it at the sky, but it's quite visible. This is something which you can also see by eye. This is the Pleiades, the seven sisters. And they're going to start appearing in the sky as we get a little bit later in the fall season. And what you can see by eye is 1, 2, 3, 4, 5 stars. If you're young, I remember being young once. And being a nerdy kid, I would use stars as eye tests. But you can see that one. So there's another one, and you can see this one down here. It's about 9 or 10 if you really look at it. As we get older, our eyes get worse. But what you see here is this is a young cluster of stars. They have burned out all the hydrogen gas and dust, and what's left, all the hydrogen gas, but what's left behind is the dust remnants, and that's what's creating that sort of cirrus-looking thing. Now we're going to go a bit further afield. I've got things a little bit out of order, but that's okay. This is a galaxy. Now, when you look at galaxies, it's important to realize we are looking through our galaxy, so you see some foreground stars. And then we're looking to this is a collection of stars. This is hundreds of billions of stars. And there's so many stars, and they're so far away, it just looks like this gentle, soft cloud. This particular galaxy looks somewhat like our galaxy would look if we were very far away. There's a disk in the galaxy which has some dust, and you can see that dark lane there. And then there's a bulge toward the center of our galaxy. So we're back now. When stars die, they do various things. And this is a picture of something called the, now I'm forgetting its name.
Hourglass.
What's that? The Dumbbell Nebula, but Hourglass would be a more picturesque name. And this is a star that reached a certain stage, a single star reached a certain stage in its evolution, and it cast off gas and dust. And so you see this, there's a star right in the center of that cloud, and the star is thrown more out along its equatorial region than along the poles. And this is just a beautiful example of this type of nebula. Now, when large stars reach the end of their life, the core collapses, and this causes the star to explode. We call them supernova. And when a supernova, this can almost completely obliterate the star. Left behind might be a very dense compressed object. You may have heard words like neutron stars or even black holes. What had happens is a large star, the inner core of the star runs out of the nuclear fuel, can no longer support itself. It collapses, and that collapse causes a bounce, and the outer layers of the star are thrown off in a gigantic explosion. There was some excitement a couple of years ago. They were talking about Betelgeuse might, we were saying, all of a sudden it dimmed by a factor of 2 or more and then brightened back up again. This was a star in our galaxy that exploded. This is the remnants of it about 10,000 years ago. And this field of view, the moon was only about this big here. This entire loop, and this is only part of it, is about 2 or 3 degrees across. The other half that's well lit, here's the bottom half. But you can see this, it's just like, a science fiction movie where you see the heroes blow up the bad guy planet or something, and you see this ring spreading out. But that's what we really see. And this is in the constellation of Cygnus. And again, a picture like this, half an hour, I tell the telescope, go to work, and I can do something else. Now we're moving out beyond our galaxy. This is Andromeda, which is the closest galaxy we can see. Again, it looks like a swirling cloud of gas, but in fact, that's hundreds of billions of stars. The dark lanes you see are gas and dust in Andromeda, and it is, the light from Andromeda has taken 2 million years or so to get here. And I'll show you some pictures where it's even further away. And just the fact that we can see something so far away is remarkable. This galaxy is visible by eye. What you would see by eye is an elongated patch. And it is probably the most distant thing that we can see by eye without any telescopes or anything. It just looks like a faint, fuzzy patch. And it's a little longer one way than the other in the constellation of Andromeda. Nearby is another galaxy. This one's more or less face on. This is the Triangulum galaxy, which is a beautiful spiral galaxy. We understand what causes these spiral shapes, and the bright knots you see along the spiral are places where there are gas and dust, some of the things I showed you up close. We see the same thing in other galaxies. They're still forming stars. Not as many today as they were a few billion years ago, but you see, in this picture, you see foreground stars. Remember, we're looking through our galaxy to look out. And then a galaxy that has hundreds of billions of stars, so it just looks like a soft cloud. And it's important to remember that of those hundreds of billions of stars, probably hundreds of billions of them have planets. And we live in this vast universe. This is an old star cluster. They're called globular star clusters. 100,000 stars. These are mostly older stars. And there are a couple hundred globular clusters that are associated with our galaxy, and we see them around other galaxies as well. Their formation is a little bit mysterious because you would have to start with a small, almost galactic-like thing, and then gradually the stars throw out all the gas and dust, but you're left behind with hundreds of thousands of stars. If you could imagine going out at night and instead of seeing 10 or 20 really bright stars, seeing 10,000 bright stars, that's what it would be like to be a planet in a globular. It would be brighter than moonlight every night.
Wow.
Going further afield, these are a couple of famous galaxies called Bode's Nebula, and Nebula AE is as in plural. These are fairly distant. These two galaxies are interacting. And what you see is that when two galaxies, it's like a slow motion interaction, takes hundreds of millions of years, that can stir up some of the spiral structure you see. This galaxy, this lower one, actually you see a little hint of it, is actually very active and is almost has a central explosion where there's been so much star formation activity triggered there that it's throwing out a lot of material. And galaxies evolve with time, just not on human timescales. This is a famous galaxy called the Whirlpool Galaxy. It's actually two galaxies that did a close collision a little while ago. And a little while, 10, 20, 30 million years ago. And that stirred up this very brilliant spiral structure. There's another galaxy with spiral structure, and I show this one. This one was discovered or cataloged by Charles Messier 250 years ago. And this particular galaxy, this was the first galaxy in which astronomers realized they saw a spiral structure. And I took this picture again. All these pictures I'm showing you were taken with this little telescope. And to see it by eye, you would need a larger telescope because our eyes aren't as sensitive as modern electronics, and our eyes don't add the light up for an hour or so. And I think this is probably my last picture. This is looking more distantly into the universe. This is a cluster of galaxies. Every one of these fuzzy things in here, and there are dozens of galaxies in this picture. every single one of them is billions or hundreds of billions of stars. So so many stars that just look like this mist. And these particular galaxies are in the Virgo cluster, and it's about 50 million light years away. And what that means is that the photons left these galaxies 50 million years ago, a little while after, but not long after the dinosaurs disappeared. They traveled straight through space, and they were perfectly happy, the photons moving along through space, and then they ran into the front end of this and got captured by a CCD camera. And so we can see them and have this picture. But every one of these fuzzy spots that you see here, there's probably 10 or 20 galaxies just in this picture alone. This is one small space. Do you want to?
Yes, so the bigger ones are because they're closer.
No, they're bigger because these are actually bigger.
Okay.
One of the ways that galaxies evolve is here you see galaxies in the process of colliding. What'll happen is the galaxies will collide and they can almost pass through each other, but the gravity effects cause them to form and deform. And so these large galaxies, eventually they kind of go like this, and you wind up with what are called elliptical galaxies, but they're kind of just big blobs of stars, but really big. This galaxy is much larger, many more stars than our own galaxy. And I mean, the universe we live in, and this is the sense of wonder that I get, it's incredibly vast. And we've learned a lot in the course of human history, and we can get into things that we don't know. And I think, here I have to do, I'm clever, it'll work. See, so this was, with a little bit of help, these days, if you just type in what are the biggest mysteries of the universe, it gives you a nice summary. I kind of modified it a bit, but I had one thing, I gave it like a 3-sentence thing, and it feeds back a little bit the point of view that you have, but you just look again and again, and there are physical mysteries of the universe, and that's what these are. What we see, all these beautiful galaxies, gas and dust, are only about 5% of what we think is out there. They're like, I read an analogy once that it is the stars and galaxies that we see are like foam on a black ocean. We can see the foam moving in the waves, but we don't see the ocean at night. And that's, this mention of dark matter and dark energy. Dark matter there is matter out there that interacts gravitationally. We can see its effect on the stars and the way they move. It's very clear that it's there. First hints of this were discovered more than half a century ago. And so we know it's there, but we don't know what it is. And there's very active research. That's something I think we eventually will know. Don't know when. But and then dark energy is to understand the overall large-scale structure of the universe that we see, that there seems to be this energetic force that's actually causing on the very largest scales for the expansion of the universe to not just stay constant, but to actually grow. But dark energy, you can say, here's a mathematical equation that describes what we see and how it behaves. But again, and we even know, it's got to have this much energy associated with it, but we don't know what it is. And then you get into, the origin of the universe and what is time and gravity. And some of these things, as a scientist, you can study. And other things become these mysteries that we're not going to make a lot of progress. But we've learned a lot. But we still don't know. Science doesn't tell you the why. It can just tell you how.
So let's see if we can, Richard, bring this all together here. It appears, or it seems from what you're saying, that we have this incredibly vast universe. Scientists think it's roughly 13.8 billion years old. So on time scales too that are impossible for us to really wrap our minds around. And this universe is filled with billions of galaxies that are filled, each galaxy filled with billions of stars. Many of those stars may be have planetary systems as well. We know there are lots of exoplanets out there, but we don't know how many. So you're talking about just an absolutely enormous, beautiful, vast universe that, again, it's very difficult for the human mind to really grasp. And all of that stuff we were just showing us is about 5% of what we think is out there, the ordinary matter that we can sense through telescopes. But there's this other stuff, dark matter, whatever that may be, that is being impacted by gravity, and then this force that's pushing the universe to expand. And the universe is actually expanding faster than the speed of light. Why did this all start 13.8 billion years ago? We don't know. We can trace things back to a moment, what we call the Big Bang, of this incredibly hot and dense moment in which all of the universe is packed into this. But why is it there? Why did it start to expand? We don't really know.
Well, in some sense, the question you ask a scientist is the how.
Yeah.
And the question you ask Justin
is the why. Oh, that's good. Yeah.
But,
and then, of course, we're left with what is gravity? Maybe dark matter somehow connects to our theory of gravity, and we don't really understand gravity at the fullest level, right? Mm-hmm. Or time. What is time exactly? It's still very much a mystery.
And if you read about the the current cosmology that hangs together pretty well, and in fact has been very powerful in predicting what we can go out and see and some of the fundamental fluctuations. And now we're looking at scientists look very deeply into the universe, looking for small deviations from what the standard cosmology tells us, because that's going to be hints towards a deeper understanding.
So given all this, Richard, you work as a scientist. You think about the how, as you put it, how our physical universe is structured and works, and some of its history. But there's obviously a lot of mystery, and mystery you can see even just from a pretty simple telescope. You're also a person of faith. You're part of this church community. How do you bring these two worlds together? How do you think about your religious life, your Christian faith, interacting with your work as a scientist?
Well, the word mystery here is very important. I think that I've been on both sides of the aisle, so to speak. Yeah. That I went to church when I was a child and so on, and drifted away, I think if you'd asked me in my 20s, I said, "Oh yeah, I'm an atheist." And as a scientist, you can say, "Well, we're going to find out this and that." But if you think about it deeply, there are things, and I've hinted at here at it. There are things we are not going to know the why, and there are also things that we can exist that we know about that are complete mysteries, despite thousands of years of human thought and effort. Right. Some of the biggest mysteries that I think that we all experience is consciousness. That each one of us knows inside of ourselves we are who we are. We can think about, we can act, we can make choices. And on the science side, we've learned a lot about the machinery that supports our consciousness. But we're no closer to understanding consciousness now, other than it's really just philosophical musings, some of which are very interesting. Right. But as a scientist or a physical scientist, you say, okay, that's very nice. Yeah. And so you want to study more, what is it that supports consciousness? But if we understood what consciousness was, maybe we will one day. Maybe we will create conscious entities.
Well, right. And this, so
we're
interesting.
A long ways away from it.
You brought this up because you'll notice this in articles you read or if you watch documentaries and so forth. there's this implicit philosophical assumption that many scientists hold, but not all, of course, that the brain somehow generates your consciousness. That is not a scientific claim. All we have are correlations between conscious mental states and brain activity. And this is a big debate, of course, in philosophy of mind, is what is the relationship between the brain and consciousness? Is consciousness generated by the brain in some sort of physical way? Or is there a interaction beyond the physical there? And that's a whole, but sometimes when you're reading articles about these things or whatever, you have to think through it a little bit as you're getting at what are the assumptions that might be operating in how things are framed. And this is one of those great examples. I mean, another would be when people say that science can explain why there is something rather than nothing, right? Another famous example. We could keep tracing this stuff back and back and back, and maybe there's something even before the Big Bang. But ultimately, why is there even a universe at all? Why is there anything rather than nothing? This is one of the great philosophical, theological questions, right?
And it even gets down to, in our universe, as you study physics and so on, there's all kinds of different places where physical constants appear. Right. You've probably heard of, the gravitational constant, or somebody, appears in this equation, GMM over R squared, right. For those of you who have had a little bit of exposure to that. But this constant of gravity it measures the strength of gravity. That's exactly what it is. And why is it that number, not some other number?
Right.
You can very quickly, and there's other subtle constants in the way that atoms and molecules interact that allow chemistry.
Right.
And if it wasn't for chemistry, that's what allows life.
So yeah, you're talking about what philosophers will call the anthropic principle. I think you mentioned it here in one of these. And the gravitational one's fascinating, right? Because if the strength of gravity were even a little bit stronger or a little bit less, the universe as we know it would never have formed, and you and I wouldn't be here having this conversation. So sometimes people see it as almost as though our universe was fine-tuned for life. That may sound like a sort of design argument, and some philosophers take it that way, but it's debated. Yeah,
depends on which tense of that verb.
Yes, right.
Is fine-tuned for life.
Right.
But there's another thing that's mysterious that we've all experienced, and this is personal things that I've also thought about is we live in a universe where love exists, and as you mentioned last week, and as many of us know, that part of Christian theology is that God is love,
right? And
then the scientists or the people who like equations will say, well, if God is love, then love is God. And when you look at that, love doesn't, some people will try to reduce love to some sort of biological or evolutionary necessity. Does your dog love you because they love you or because they're hungry? And we have
maybe a little bit of both, right?
and there is a little bit of both of that.
Yeah.
But it's also something that we experience. Why do we help somebody who's helpless, who's not related to us? We don't even know where does altruism and all these other human impulses come from. Right. And at the root of all of that is love. Right. Love for not just ourselves, but for our family or community, but love for others, even strangers. Right. And all of us, I'm sure, have taken on things where you do something out of love for others, even though, expressing that love or the sacrifice you make doesn't benefit you. And so as a scientist, I observe these things, and I can separate, there's things we can study empirically. I think about Job chapter, 38, where God questions Job. Mm-hmm. Who are you? Right. And I say, well, yeah, actually, we know the answers to some of these questions. Right. But very quickly, those questions coming from God get into things that, you're right. We don't know those, and we're not even close. So Richard is talking about the book of Job, chapter 38, where Job is trying to figure out the meaning and purpose of the universe, and in particular, the problem of suffering.
Why is it that people suffer? Why is it that bad things seem to happen without any kind of deeper meaning that's at least clear to the mind? And he's bringing his case to God, basically. And God's response is very interesting. It is basically, where were you when I created the universe? As in, this universe is so beyond what a human mind could possibly ever grasp. And to try to sort of simplify the complexities and depth of the universe by human categories is to somehow miss the whole mark. And it, in one sense is maybe unsatisfactory because we want the answer to just be given to us, but the point is that the answer almost can't be given to us. It's beyond what a human mind can really fathom. And it's a powerful image.
And I think, as I show you these, this beautiful universe that we live in, and you can just take your eyes outside and look at life growing all around us. Take a microscope and look at little tiny things, and on either direction we look, it's all so beautiful. And I think, whether it's a sunset or a waterfall or the face of somebody you love or whatever, and this was the epiphany that I had many years ago that brought me to faith, is this feeling of gratitude for this beautiful, incredible, difficult, challenging, painful, but still beautiful world that we live in.
Yeah. And what's interesting about what you're saying, Richard, is that part of this is also about how you choose to look at the world. Because, you will sometimes hear people, and especially scientists say, well, there is no meaning and purpose in the world because, look, it's so vast, it's so enormous, we're just this little species on this little planet, and da-da-da. This is sort of an image that, an idea Carl Sagan actually popularized in the 70s. But you could look at it from a completely different point of view, the same data, the same information, just the way you were right there, and say, no, actually, we find this world that even in the midst of this vastness and seeming coldness, there is love, there is beauty, there is goodness, and there is a kind of meaning and purpose shot through all of reality. You're looking at the same information, but you're framing it in a very different way.
And I think that, and some of this is what we bring to it, and it's what I bring to faith, is that this deep sense of gratitude and wonder. And, if you just pick up the newspaper, if you read newspaper anymore, but
what is that?
But looking at the news, there's a lot of difficulty and terrible suffering in this world.
Yeah.
Much of it that we inflict upon ourselves. And despite all that, we still can be grateful. Despite the darkness, we can look into the darkness with love and wonder and try to shine a bit of light and a bit of understanding into that darkness.
Yeah, absolutely. Well, that's a good note to maybe open it up for questions. What questions do you have? Yeah, Randy.
Okay, 3.
All right, choose one.
I kind of always, in a setting like this, I always think, if my grandson asked me blank, how would I respond? How would I answer? I'm going to give you 3 that I'm curious about. Relative to our Earth, how big is the moon? Second is, when you say galaxy, I don't think I can answer that question. What is a galaxy? And here's a real basic one. What is a star? I can't tell you what a star is.
Okay, let's start with, here's the Earth, and here's the moon. The moon is about around a quarter the size of the Earth. It's also about 80 times further away. So if here's the Earth, the moon's going to be way over there and like this. Space is vast and these things are small.
Yeah.
Well, going to a bit bigger, what is a star? A star is a place or a physical entity where gravity has acted to collect gas. You start with a large, loose cloud of gas and dust. And as it collapses, it gets denser and denser. And the clouds in space are mostly hydrogen with a little, now that the universe is a little bit older, with a little bit of fun stuff mixed in like carbon and oxygen and nitrogen and phosphorus, things that we need for us to be here, that were produced by the earliest generation of stars. And so a star is simply, basically, the sun, for example, is made of hydrogen gas. It's hugely massive. On the outside, it's very low density and transitions to the vacuum of space. But down at the center, it's incredibly hot and dense. And that's just from the gravitational compression. It's made it hot and dense. It gets so hot and dense that the atoms have all of their electrons stripped off. So now you have protons and electrons zipping around and neutrons. And it's so hot and dense that they can fuse together in the same way that in a nuclear reaction, and that releases energy. So that energy that's released at the center of the sun gradually filters out and supports the whole thing from collapsing. When the sun runs out of hydrogen to burn, it will go through some phases and it'll start combining. It has to get hotter and bigger to do this, but eventually it runs out of stuff, and its ultimate fate is it will just shrink down and slowly into a what we call a white dwarf star. We see these in many places, which are around the size of the Earth and very hot and dense matter that there's not enough heat for it to do nuclear fusion anymore, and it'll just gradually cool off over the next few 100 billion years.
So I missed it.
So okay, oh yes, so a galaxy is the entire universe. When the universe began, this is a bit mysterious, but the universe formed. There are various theories about how this happened, but with small irregularities as it began from the Big Bang and expanded. The Big Bang was infinite in size, but also infinite in density. It sounds like a little bit of a paradox. Yes, we're still working on that. But as the universe expands, the density falls, and these small irregularities that are in there are enough to cause those areas to collapse into gravitational collections. And we call those galaxies. And inside the galaxies, there's enough gas and dust that they start forming stars. So very within the first, and we're using telescopes now like the James Webb, which is just launched a couple of years ago, that telescope is looking at some of the most distant galaxies, and the mystery that's turning up is we're seeing a little more stars than we expected in the part of the universe that we can see that's very distant. Astronomy is a time machine. You know, when I'm looking back with this telescope, I showed you it's easy to see stuff that's 50 million years ago. That's what the universe looked like in that area 50 million years ago. Well, astronomy can see all the way back to nearly 13 billion years ago. So you're looking at back in time at the universe when it was young, when galaxies were forming out of this primordial soup due to gravity, and then stars within those galaxies began to form again by gravity pulling the local stuff. It's unstable, so it collapses.
Good?
I just can't imagine. I hope my grandson doesn't ask me that question.
I mean, maybe one simple way we could put it is just
you can
like,
get him a little telescope and you can start taking pictures of it. Though.
you know, I'll put it in like geographic terms. Like we could say maybe a galaxy is like a country, right? And every star, like our sun, is like a state. And within each of those stars, you have perhaps planets orbiting them, which we can think of almost like little cities within the area. So it's also a scale thing, basically. That's a way to think about it. Yeah, Ron.
So I'm curious. So if we're on Earth and we're in the Milky Way, right, and we are in the Virgo cluster, and then we get to the Laniakea supercluster, where is that supercluster? Is that in our universe, or is that another universe? Have those definitions rippled out to another universe? course, that's still in our universe.
Can we speak about, I know it's a speculative thing, right, but other universes beyond our universe?
Okay, and to get to Ra's question a little bit, is that what we see as we look at the largest scales in space, and there's very active study going on, is that we see very large, I showed you a little bit of the Virgo cluster. The Virgo cluster itself has several thousand galaxies in it.
Mm-hmm.
And this is one of the denser parts near the center. And we see many clusters of galaxies. And then you referred to there are superclusters. If we look at the very largest scale structure of space, I'm trying to, it's this kind of, if you imagine this kind of airy structure with threads and sheets running through it and mostly empty, there are places in the universe that are vast and nearly empty, and then other places on lines and clusters and things where you see galaxies have collected. So I'm trying to think if you've ever seen, it's like a low density sponge almost. If you imagine something that's spongy, or imagine if you had a bunch of lumpy styrofoam that you could bend and push it all together. There'd be places where you had this styrofoam together, but then there'd be a lot of empty holes in between. Yeah. And that's what our universe looks like. If you look at, another thing would be looking at, say, the foam on water. When you've seen that, you'll see big empty stuff, but then you'll see the bubbles and foams. And so we're on those bubbles and foam spaces. We can model all of this, but then you get to this question, are there other universes? Either there's one or there's an infinite number. And people speculate about this and say, well, if there are other universes, is there some way to see their shadow or their effect in ours, or is our universe it? And it very quickly gets out of the realm of science and into the realm of philosophy.
Right. So we have essentially no empirical evidence that there are any other universes beyond our own. We may never be able to know that one way or the other.
It's remarkable that we can think about it.
It is remarkable. It's remarkable that we can use these minds of ours to understand as much as we can, right? And that we've created this technology that's pretty basic that allows us to see the vastness of our universe. Any final thoughts, Richard, you want to share with us about kind of what all this means for you?
Well, as I think that, starting with this feeling of, if you've got, like watching a sunset or looking out at the beauty of the stars at night, if you're an astronomer, or seeing a child running through the store with just this look of pure joy as her mother and my wife were chasing after this 3-year-old the other day, and the kid had just this glorious feeling of joy, and to feel gratitude to be alive and to see those things is really important. To embrace that gratitude, to embrace the love, and say we can learn a lot, and the scientific knowledge that we've gained over the whole course of the scientific enterprise has benefited all of us, but it still leaves us, you can either say, oh, we can reduce everything to bits and bytes and all of that. But I think it just, to me, as the deeper we have an understanding of what the universe is, the deeper my gratitude and wonder grow.
Yeah.
That science increases that in somebody like me.
It seems as though actually the more we've learned over the 20th century, 21st century, the more mysterious and wonderful the universe has actually become for us, and less sort of reduced just to the bits and the bytes, as you said.
Yeah.
Well, thank you, Richard, for being with us. Go in peace to love and serve the Lord. Thanks be to God.